Hi everyone. Today's video is on completing the square. This is one of the questions that I get asked all the time by students, is whether they're learning it or they kind of forget it when they come to grade 11. Completing the square is one of those techniques that you need to know and you need to practice to make sure you understand. So first of all, I kind of want to go over how all of these things are related. So in the video previously, we looked at going from factored form to standard form. So we looked at expanding binomials. So for this for this arrow to go from factored form to standard form, you are going to expand. Okay. Same thing over here. If you wanted to go to vertex form to standard form, we did an example like this, you would also expand. Okay. And we also did a couple of videos from going from standard form to factored form. So here we would actually factor. Okay. But what we're going to look at in today's video is going from standard form to vertex form. And this is where we're going to complete the square. And the reason that we want to complete the square is that it will put our equation into vertex form, and vertex form is very handy for graphing quadratic equations, and for answering some of those questions. If you want to know how high something went or what the max value is, all right, all of those questions, completing the square makes it very easy to answer that. All right, so let's take a look. So a simple trinomial, we can complete the square. We're going to go through the same steps as if we were completing the square with something more complicated. But what we're going to do is we're going to start by factoring out whatever is common in these first two terms. In this case, it's only 1, but we're going to still pretend to factor out that 1. I'm not going to write it, but I'm just going to write x squared plus 2x in a set of brackets and leave negative 15 hanging out on the end. This makes a lot more sense when we look at something more complicated like example number 2, but we're going to keep the steps the same just to keep it nice and easy. Now, what our goal is to put a perfect square trinomial into that bracket because we want this to look like vertex form. So we need x plus or minus something squared. So we need to create that equation. So we're trying to figure out a number that we were going to add into our brackets that's going to make this trinomial inside of our brackets a perfect square trinomial. The way that we do that is we take this middle term here, we take whatever's in our brackets, we're going to divide it by 2 and then square it. So 2 divided by 2 is 1, squared is 1. So 1 is the number that we're going to add and subtract into our bracket. So it's going to look like this. X squared plus 2x. Now, I'm going to change the color just to kind of, make this a bit easier to see. So I'm going to add 1, but I can't just go ahead adding 1 into any equation. I want to keep this equation the same. So I also have to subtract 1 in my brackets so that I don't actually change the value of my equation. Okay, so I have the negative 15 hanging out on the end. Now, in my brackets, I only want 3 terms. I only want that trinomial. So I'm actually going to kick this negative 1 out of the brackets. But in order to do that, I would have to multiply it by anything that's out in front. In our case, there's only a 1 out in front. So it's going to look like this. X squared plus 2x plus 1. Then we're going to have negative 1 minus 15. Now what we're going to do in our brackets here is we're going to factor this. So 2 numbers that multiply to 1 and add to 2. All right, and I'm going to you can skip some steps here. Whoops, you can skip some steps here as you get more comfortable. So we're going to have the 2 numbers that multiply to 1 and to add to 2 are both 1, so 1 and 1. So we're going to have x plus 1 times x plus 1. And we're going to simplify the terms on the end. So negative 1 minus 15 is negative 16. And then we're going to write this as that perfect square trinomial. So if you remember from our factoring videos, we would write this as x plus 1 squared minus 16. And this would be our equation in vertex form. Okay, let's do it again. Something slightly more complicated. So over here, we have a 4 out in front. So what we want to do is we want to factor that number, that 4, out of the first two terms. The 7 is fine. The 7 is going to hang out on the end. So it's going to look like this. So we're going to have 4, and then open a bracket. 4x squared divided by 4 is just x squared. And negative 8x divided by 4 is negative 2x. Now, some people will say, but you could have factored the x out. Yeah, you're right. We could have factored the x out, but that won't give us what we want. We're trying to build a perfect square trinomial in this bracket. So we have plus 7 still hanging out on the end. Now, very similar example to the one we did before. Here it's negative 2. We want to figure out what number to add and subtract in the brackets. So negative 2 divided by 2 and then square it is the trick. So we have negative 1 squared, and then that's going to be positive 1. So positive 1 is what we're going to be adding and subtracting in the brackets. So we have 4 times x squared minus 2x, and I'm going to change my color again just to make it a bit clearer. So then we're going to add 1 and subtract 1. You always want to put the positive number first. So always adding first, because in that perfect square trinomial, your last term has to be a perfect square, and negative 1 is not a perfect square. And then we have a positive 7 hanging out on the end. Now, same steps as before, we want to kick this negative term out of our bracket, but in order to do that, we need to multiply it by whatever is outside of the bracket. So we have 4 times x squared minus 2x plus 1, close our bracket, and then 4 times negative 1 is negative 4 plus 7. All right, so now we're going to factor our perfect square trinomial. So we have two numbers that multiply to 1 and add to negative 2. So that would be negative 1 and negative 1. So you can write this step if you'd like. So x minus 1 times x minus 1. Or you can jump right to x minus 1 squared, depends on your preference. And our final equation is x minus 1 squared plus 3. So if you're comfortable, you could skip right from this step to this step if you're comfortable and if you'd like to. Okay, let's do a couple more examples. So I find that anytime that you're trying to complete the squares with fractions, it really strikes fear in the hearts of students. So I have one example for where it works out really well anyways. It's okay. So here, students I have often will see a fraction and just panic. But sometimes the fraction's not so bad. So what we want to do, same steps, we want to factor that 1/2 out of those first two terms. Remember, just the number, not the x. So we're going to have equals 1/2. That leaves us with x squared. And then if you divide negative 3 divided by 1/2, you actually get 6. And that actually will work out quite nicely. So in figuring out what number we're going to multiply or divide into our bracket, we're going to say negative 6 divided by 2 squared, and that gives us negative 3 squared, or positive 9. So that's what we're going to put in our brackets. We're going to add and subtract in our brackets. So 1/2 times x squared minus 6x. I'm going to change my color again. All right, so I'm going to have plus 9 minus 9, because I don't want to actually change the value of my equation. Close my bracket, and I have that positive 4 hanging out on the end. So now I want to, again, kick that negative 9 out of the bracket. So I need to multiply it by 1/2. So this is where it's important that we have some fraction practice. So x squared minus 6x plus 9. And then 1/2 times negative 9 is negative 9 over 2. For my students, I say, unless there's a decimal in the question, I don't want to see a decimal in your final answer. So it is important to get comfortable multiplying, dividing, adding, and subtracting fractions. Okay, so we're going to factor our perfect square trinomial. So two numbers that multiply to 9 and add to negative 6 is negative 3 and negative 3. So 1/2 times x minus 3 times x minus 3 minus 9 over 2. And I'm going to take a second and write 4 as something over 2. So I'm going to write that as 8 over 2. We'll scroll down a bit. I'm at the bottom of my page. Okay, so then we have 1/2 is equal to x minus 3 squared minus 1/2, because 9/2, negative 9/2 plus 8/2 is negative 1/2, and this would be your final answer. Okay. Now, sometimes when something looks okay, so it looks like it has all whole numbers, sometimes we end up with a fraction in our equation, and it's actually much easier to deal with than you might think. So let's start by factoring that positive 2 out of those first two terms. So we have 2 times x squared, and this is where we run into problems. So 5 doesn't divide, or 2, it doesn't divide evenly into 5. So let's write this as plus 5/2 x and then minus 4. So this is now our b term. So we're going to write it like this: 5/2 divided by 2, right? And then we square it. So 5/2 divided by 2, so it's like multiplying by 1/2, is going to be 5/4 squared. So the number that we're adding and subtracting into our brackets is 25/16, which seems like a little bit wild, but it does work out relatively nicely in the end. So 2 times x squared plus 5/2x, and then we're going to add and subtract 25/16 in our brackets. So plus 25/16 minus 25/16, and then we're going to close our brackets, and the -4 is still hanging out in the end. So even though we have a fraction in our equation, all of our steps are exactly the same. I want to kick this negative fraction out of the brackets, so I have to multiply it by 2. So we have 2 times x squared plus 5/2x plus 25/16. And then 2 times negative 25/16 is negative 50/16. And in lowest terms, that's going to be negative 25/8. All right. And then I'm going to write my, well, let's leave that as -4 just for a second. So now I'm going to factor this. So pardon me, this is where it comes in, it's a little bit tricky. So we're looking for two numbers that multiply to 25/16 and add to positive 5/2. Now, the nice thing is that number that you're going to use is always before you square it. So let's take a second and just look back up at all of these examples. So here, the number that ended up being in our bracket is the number before we squared it. Right? So the number that ended up being in our bracket is the number before we squared it. Okay, same down here. So it ends up being the number that's in our bracket when we factor is the number before we square it. That's just the pattern that happens with perfect square trinomials. So when we're figuring out what number is going to multiply to 25/16 and add to 5/2, it's going to be that number in the bracket before we square it. All right, it's always going to be that b value divided by 2. So let's write that down. So 2 times x plus 5/4 times x plus 5/4 minus 25/8 minus, and I'm going to write 4 as something over 8, so that's going to be 32/8. Okay, and if you want to double check, you can see if you can always expand it and go up a step. So 5/4 times 5/4 is 25/16. 5/4 plus 5/4 is 10/4, or 5/2. All right, and last step is that we want to write this as simplified as possible. So 5/4, x plus 5/4 squared, and then negative 25/8 minus 32/8 is negative 57/8. So like I said, you have to be comfortable adding and subtracting, multiplying and dividing fractions, but all the steps are exactly the same. All right, I hope that helped, and you can always leave me a message if you would like more examples. Thanks so much.